Good day, class. I am Mr. Christian, and for today's discussion, we will be tackling about rocks. We have several objectives. For our objectives, we are going to classify and describe the three basic rock types, establish relationships between rock types, the origin and environment of deposition or formation, and lastly, we must be able to understand the different geologic processes involved in rock formation. Now, let me ask you, what is a rock? A rock is any solid that is naturally found on Earth. So they are scattered all around us. They may consist of combinations of minerals. They may contain pre-existing rock components, or they may contain organic debris, or they may possess all of these components. So rocks are the mixtures of minerals, other pre-existing rocks, and other organic matter. Okay, so not just a single mineral is found in a particular rock. Depending on the type, there are usually two or more minerals trapped inside a rock component. Okay, so these minerals are usually quartz from silica components, from feldspar and biotite. Rocks also contain components coming from the pre-existing rocks. When we say pre-existing rocks, these are the disintegrated component of the older rock. And these older rock, due to weathering, due to the different environmental factors, they are compacted together, they are cemented together, combining together, forming a new type of rock. Okay, and also we have organic debris. These organic debris came from the fossilized remains of plants, the fossilized remains of animals, and also the waste materials of the living organisms. So they may contribute to the formation of rocks. Okay, so we must consider that a rock contains minerals, pre-existing rocks, and also some organic debris coming from the living organisms. And they get compacted, they get cemented, forming a single mass due to weathering, due to the interaction of water, and they get cemented with one another. Okay, so just like the rocks that you are seeing in your surroundings, we call it as the common rock, wherein it contains the combination of quartz, feldspar, and biotite. Depending on a type of rock, they vary in volume. It may be that this rock contains more quartz, that this rock contains more feldspar, and less biotite. Okay, depending on a type of rock. Now, rocks are categorized into three types. We have the igneous rock, sedimentary rock, and the metamorphic rock. For the igneous rock, it is usually formed through the cooling and the hardening of magma or of the lava. If the magma cools and hardens, then an intrusive igneous rock will be formed. If the lava cools and hardens, then an extrusive igneous rock will be formed. You try to observe. On the left side of your screen, we have an obsidian. An obsidian is considered to be as intrusive igneous rock. An intrusive igneous rock usually develops from the cooling process of magma and also from the hardening process of magma. They usually develop larger crystals. While the extrusive igneous rock, you try to observe the basalt. They are usually abundant in the seafloor. Now, basalt cools fast, that it fails to develop larger crystals. That's why it's dull in appearance, meaning it's not that shiny compared to the obsidian under intrusive igneous rock. Okay, so for basalt, since it is an extrusive igneous rock, meaning to say it cools on the surface, it cools at a faster rate that it fails to develop larger crystals. Okay, so from lava, it cools down, forming the basalt. Okay, so those are the different types of igneous rock. We have the intrusive igneous rock and the extrusive igneous rock. Always keep this in mind that when magma or lava cools and hardens, then an igneous rock will be formed. Okay, so what's the difference between intrusive and extrusive igneous rock? For intrusive igneous rock, they are usually formed below the Earth's surface. Okay, below the Earth's crust. While extrusive igneous rock, they are formed from eruptions wherein they cool on the Earth's surface. Okay, so that's the difference. Igneous rock are divided into two types: the intrusive igneous rock, which cools underneath the Earth's crust, while the extrusive igneous rock, which cools on the surface of the Earth's crust. Now, intrusive igneous rock usually cools down from magma, while the extrusive igneous rock forms when lava cools down on the surface. And lastly, since intrusive igneous rock is trapped inside the Earth's crust, the cooling process is very slow, wherein it is capable of forming larger crystals, since the cooling process is slow. While extrusive igneous rock, since the cooling process is very fast, it fails the crystals to grow at higher amounts. That's why they usually have smaller crystals or no crystals at all found in an extrusive igneous rock. Okay, so those are the difference between the two types of igneous rocks. Now let's proceed to the formation of igneous rocks. So for the intrusive igneous rock, usually it is formed inside the Earth's crust. Okay, this portion here, inside, meaning below the Earth's crust. So this portion here, we can see several intrusive igneous rock, as long as it is nearly exposed to magma, or it is highly exposed to magma. While the extrusive igneous rock, they usually form on the surface. Okay, so if the magma oozes out from the volcanic vent, it turns into lava. Then the lava, it is exposed to the atmosphere, allowing the heat to escape at higher pacing at shorter time. Heat will then turn the lava hard, allowing it to form the extrusive igneous rock. Okay, so again, let me repeat my statement regarding with extrusive igneous rock. By the time heat escapes at a faster pacing, the lava cools faster. If it cools faster, then crystals could hardly form, or it may be that crystals cannot form because the cooling process is very fast. So on the surface, as the lava cools and hardens, an extrusive igneous rock is formed. Okay, so those are the difference between extrusive igneous rock and intrusive igneous rock. So for the intrusive igneous rock, they cool on the inside. okay, below the Earth's crust, okay, usually here, inside the volcano or inside the crust. But for extrusive igneous rock, they usually cool on the surface, okay, usually on the outer portion, okay, here and here on the surface. The extrusive igneous rock usually cools on the surface of the Earth's crust. Okay, so those are the formations of extrusive igneous rock and intrusive igneous rock. Now let's have the other type of sedimentary rock. So sedimentary rocks are formed by the deposition and subsequent cementation of materials on the Earth's surface. Water plays an important role on the deposition and the cementation of sediments. Okay, so they are classified according to texture. We are referring to sedimentary rocks. So sedimentary rocks are classified according to texture, nature, shape of sediments, and the presence of cement. Okay, so sedimentation, it is the collective name for the process wherein a mineral or organic particle settle in place. For instance, we have liquid component here. A glass flask or a graduated cylinder is filled with water. Then sediments are poured. So let's say for instance, because of weathering, sediments are broken down into smaller pieces and later on eroded into the water bodies. Once exposed within the water bodies, the sediments will settle at the bottom. Okay? So they will sink and eventually accumulate at the bottom portion of the water body. By the time they accumulate, the newer sediments pile up above them. So sooner or later, the sediments will accumulate, more and more sediments will pile up together, pushing the most bottom component of the sediment and eventually squeezing it, cementing it until such time a sedimentary rock is formed. Okay, so it has something to do with the weight of the sediments above the other sediments. So they tend to push it, squeeze it, and cement it with the help of water, giving rise to the sedimentary rock. Now, there are two types of sedimentary rock. We have clastic sedimentary rock and chemical sedimentary rock. For clastic sedimentary rock, they are usually formed by the weathering process. Okay, breaking down larger rock component into smaller sediments. Okay, changing its physical appearance, maintaining its chemical composition. So this is for clastic sedimentary rocks. Okay, they are usually named according to grain size and the sediment particles. Okay, let's say for instance we have the conglomerate. Okay, you try to observe the leftmost picture. Okay, it's on the left side of the screen. They are usually coarse and there are also rounded grains present. Okay, so when we zoom it in, we can see some components. Okay, so they are considered to be the heterogeneous mixtures of different sediments. Okay, they are combined together under clastic sedimentary rock. We can see their components present in a clastic sedimentary rock cemented together with the other components. So let's have the second picture. We have the breccia. Okay, so for breccia, they tend to have a edge they have they contain angular shaped sediments wherein they have their prominent edges that are mixed together with the other sediments. Okay. Next we have the sandstone, this one here. This is a sandstone. As what you have noticed, the grain size tends to become finer and finer. Okay, so for the sandstone, the upper sediments tend to squeeze the lower sediments. Okay, so this one here is the upper sediment, and on the other side we have the lower sediments. These are the arrangement of sediments in nature. So let's try to mm, make the sandstone upright. Okay, so this sandstone here has several layers. Okay, as what you have noticed on this layer here, they are found on the upper portion of a sandstone. Okay, since they are found on the upper layer, their gaps in between are quite thick. Okay, meaning they are less compacted compared to the bottom portion. You try to observe here, they are highly compacted together in a sense that the pressure from the above layer pushes it down, squeezing it, making it very compact. With the help of water, they will unite, forming the sandstone under clastic sedimentary rock. Okay? And lastly, we also have the shale. Okay? It's on the rightmost portion wherein the grains are having less than 1/16 in millimeter. They get finer and finer, layer by layer. Sediments pile up, forming a clastic sedimentary rock. So these are sediments in which their physical or original form was changed into smaller ones and eventually joined together again. So that is for clastic sedimentary rock. For chemical sedimentary rock, it contains materials that are formed by chemical precipitation of minerals as a direct result of physical processes or an indirect processes of water-dwelling animals, such as limestone, dolomite, gypsum, and halite. For limestone, it is the most abundant chemical sedimentary rock that is formed as part of life processes of water-dwelling animals. So limestone combined together with water plus the other sediments. Why it is considered as chemical sedimentary rocks? Because the mixture was changing. Okay, let's say for instance limestone mixed with water, mixed with other sediments. By the time the water starts to evaporate, leaving the sediments behind, the precipitates will form, changing the mixture, leaving the precipitates behind. The precipitates are the limestone and the sediments. They are already cemented together. They are already um, combined together through the presence of water. Okay. Next we have halite. Okay. So sodium chloride was combined together by the water with another sodium chloride. So I would like to emphasize halite here. So halite is considered to be as salt. Okay, so we also have other chemical sedimentary rocks such as dolomite, gypsum, and halite. But I would like to emphasize the presence of halite, meaning to say sodium chloride are combined together with the help of water. So water acts as a mixing compound wherein they tend to bind one sodium chloride with the other sodium chloride. By the time water evaporates, it leaves the precipitate behind, forming the salt, changing its chemical composition, wherein it looks like this one, halite. Okay? Now, let's proceed to another type of rock. We have the metamorphic rock. So metamorphic rock are usually formed under the surface of the earth from the metamorphosis that occurs due to intense heat and pressure, squeezing the rock component, changing its type. When igneous rock is exposed to extreme heat and pressure, then it could possibly form into metamorphic rock. Sedimentary rocks, when exposed to extreme heat and pressure, then it can turn into metamorphic rock as well. Metamorphic rock exposed to heat and pressure, then it can possibly turn into another type of metamorphic rock. So that's the property of heat and pressure, allowing it to recrystallize, change the rock type into another rock type. So metamorphic rocks often have ribbon-like layers, and many have shiny crystals. Okay, so ribbon-like layers, we are referring to the bonding. We are referring to the striations or the stripes found in a particular rock type, in a particular metamorphic rock. So they are usually formed by minerals wherein it grows slowly over time, increasing the crystal formation on their surface. So these are some of the examples of metamorphic rock. We have amphibolite, gneiss, hornfels, marble, muscovite schist, and phyllite. So under these different types of metamorphic rocks, they follow a certain pattern. Some of them are classified to be foliated metamorphic rock. Some of them are classified to be non-foliated metamorphic rock. For the foliated metamorphic rock, you try to observe gneiss and phyllite. Okay? As what you have noticed, they have striations or they have stripes within them. Okay? These stripes are formed layering the metamorphic rock. As what you have noticed here, it follows a ribbon-like arrangement, a banding or striations. This is being categorized as foliated metamorphic rock. Usually they have less crystal formation. But for the non-foliated metamorphic rocks such as amphibolite, hornfels, marble, and muscovite, they usually develop larger crystals compared to the foliated metamorphic rock. So it looks like this one. Foliation refers to the arrangement of mineral crystals in the metamorphic rock and is often exhibited by those that are formed by regional metamorphism. So foliation is categorized into foliated metamorphic rock and the non-foliated metamorphic rock. For the foliated metamorphic rock, they exhibit parallel alignment of minerals, wherein there is also a compositional banding wherein light and dark minerals generate a layered appearance. Okay, so it's the difference between dark and light components. It may be that they have different components involved. It may be that a darker mineral is mixed with a lighter mineral, or it may be they vary from heat and pressure, causing them to form bonding, causing them to form foliation, such as gneiss. As what you have noticed here, there are layers of minerals forming gneiss. We also have hornfels. They tend to develop striations or bondings. We call them as foliated because of the foliation found within them. Okay, so this is a type of metamorphic rock, and we also have the non-foliated metamorphic rock. For the non-foliated metamorphic rock, they produce with very little deformation with a parent rock, and they have equidimensional crystals. When we say equidimensional crystals, crystals are scattered all around a particular non-foliated metamorphic rock. They are usually distributed all throughout the surface and on the inner side of the non-foliated metamorphic rock. So the resulting metamorphic has large interlocking crystals. They are usually having more crystal volume than the foliated metamorphic rock. Okay, so that is randomly oriented and is formed from the recrystallization of the smaller crystals. Now, the non-foliated metamorphic rock looks like this one, the quartzite and the amphibolite. Okay, so here there are crystal formations within them on a small scale, but there are also larger crystal formations. Okay, such as we have the diamond. Okay, so diamond mixed together within the rocks, and here for the amphibolite, it doesn't contain diamond, but there are crystals. The white spots here, it contains crystals. Okay, so always keep this in mind, that a particular mineral can get attached to a certain rock. A certain type of mineral is broken down naturally due to the geologic processes and can combine to a type of rock when exposed with different environments such as magma, such as intense heat and pressure, such as we have the metamorphism of a certain rock. Then a mineral can easily mix or combine in a rock. Okay, so we have the non-foliated metamorphic rock. So what is metamorphism? So metamorphism is the process wherein it allows a certain type of rock to change into another type of rock. It allows the crystals to recrystallize once exposed to different heat and pressure, usually intense heat and pressure. So metamorphism comes from the Greek word meta, which means after, and morph, which means form. So it refers to the changes in mineral assemblage and texture that result from subjecting a rock to conditions such as pressure, temperature, and chemical environments different from those under which the rock originally formed. Okay, so here we have the factors which speeds up the metamorphism: heat and pressure. As a certain rock or mineral goes deeper within the crust, then temperature will slowly increase, pressure will slowly increase as well, allowing it to recrystallize, allowing it to form into another type of rock, such as this one. So shale can transform into slate once exposed into higher temperature and higher pressure. So slate, through time it goes deeper and deeper underneath the Earth's crust. Later on, as it goes deeper, the temperature increases, the pressure increases as well, changing slate into phyllite. Phyllite, exposed to more heat and pressure, then it turns into schist. More heat and pressure, schist can turn into gneiss. More heat and pressure, gneiss can possibly then melt and gets mixed with the magma. Okay? So for increasing heat and pressure, there is also an increasing metamorphism, allowing a certain type of rock to change into another type of rock due to an increase of heat and pressure. Okay? Next, we have the crystallization. So crystallization is the process of the formation and growth of individual mineral crystals. So minerals are the building blocks of rocks. Without minerals, then rocks could hardly form because minerals are the foundations of rocks. Crystallization from minerals allows the rocks to be formed, allows the rocks to grow bigger in size as the geologic processes continue to take place. So it is the environment where crystallization occurs determines the type of rock that is formed. Okay? For instance, if the formation occurred underneath the Earth's surface, then it is called as intrusive or plutonic igneous rock. On the other hand, if the formation of igneous rock took place on the surface of the Earth, then it is called as extrusive igneous rock. There are crystals formed in between igneous rock and metamorphic rock. So for sedimentary rocks, there are some crystals as well, but it is not that abundant compared to igneous rock and metamorphic rock. Okay? Now, crystallization means that all minerals must form through the crystallization process. It's the repetitive arrangement of atoms. So atoms are the ones responsible for the crystallization of minerals, for the crystallization and binding of minerals. Crystallization is when atoms are arranged to form a material with a crystal structure in a repetitive manner. Next, we also have the opposite of crystallization, the recrystallization. So it is the most common metamorphic process by which crystals are packed together, creating a new crystal structure. Recrystallization requires a lot of heat and pressure, and the process changes the mineral's size and shape, yet the basic composition remains the same. For example, we have limestone. Through recrystallization, a limestone can turn into marble. Okay? Since limestone contains tiny calcite crystals that come from shells or marine organisms that are broken down and compacted into sedimentary rocks, during recrystallization, this can still be found inside a marble. Okay, such as this one. We have some examples of recrystallization. Let's say, for instance, we have the protolith sandstone. When we say protolith, it's the original form. That when recrystallized, a sandstone can turn into quartzite. Okay, maintaining its composition, but the arrangement are slightly changed. Okay. Next, we have limestone, the protolith, the original structure. Once exposed to higher heat and pressure, the limestone can change into marble. but maintaining its components, but the arrangement are slightly changed. Okay, meaning to say they are being metamorphosed. Okay, so these are some of the examples of recrystallization. So we also have different types of metamorphism, which contributes to the recrystallization, crystallization of rocks. So, contact metamorphism, burial metamorphism, and regional metamorphism changes a particular rock into another type of rock upon the exposure of magma, upon the exposure of heat and pressure. So for contact metamorphism, it happens when magma intrudes a cooler rock, exposing the rock to higher temperatures but not to higher pressure. Let's say, for instance, in a volcanic eruption, a magma gets contact with a cool rock. Once a cooler rock is in direct contact with magma, it melts. As it melts, it turns to become a metamorphic rock, or it turns to become an igneous rock. Okay? But more with igneous rock because of the absence of high pressure. Okay? Next, we have another example here. We have volcanic eruption. It refers to the intrusion of magma. When we say intrusion, it's the appearance of magma on the surface, exposing the rock with a magma, melting it. So this is considered as contact metamorphism. Next, we have burial metamorphism. It occurs when sedimentary rocks had undergone diagenesis and are buried even deeper. When we say diagenesis, sedimentary rocks are changing because of heat and pressure. So for burial metamorphism, let's try to consider the oceanic crust and the continental crust. Since the oceanic crust is denser, it allows the oceanic crust to sink, to get buried underneath the continental crust. So there is this burial metamorphism happening here. The burial metamorphism induces heat and pressure, changing the sedimentary rock components into another type of rock, usually metamorphic rock, because it has something to do with heat and pressure. Okay? Now, we also have another type of metamorphism, regional metamorphism. For regional metamorphism, it occurs when a large mass of rocks are exposed to differential stress and to high temperature. Okay, so we have the collision of different types of rocks. So for regional metamorphism, let's say for instance, we have convergent boundary. Okay, so from two different rock types, they tend to collide. Upon their collision, they get squeezed, pressure is increasing, and temperature is increasing as well because it is situated near the magma chamber. Now, this regional metamorphism allows the contact of two rocks, squeezing them apart, changing its form, allowing it to undergo metamorphism. Okay, so these are the different types of metamorphism. Okay, so contact metamorphism, burial metamorphism, and regional metamorphism. Okay, and lastly, we have the three major types of stress in the Earth's crust. We have the compressional stress, or the convergent boundary. We have the tension stress, or the divergent boundary. We also have the shear stress, or the transitional boundary. Okay, they slide past against the other, such as this one. For tension stress, two separate plates can move farther away from the other, or the ends of the plate can move in different directions, okay, creating gaps in between them, okay. So this is under divergent boundary. For compression stress, a type of stress that causes the rocks to push or squeeze against the other, okay, allowing them to collide, allowing them to form mountains, okay, or even new islands. That's for compression stress. And rocks are exposed to extreme pressure, and they could possibly change. And lastly, we have shear stress. It happens when two plates rub against the other, moving in opposite direction, okay. Let's say, for instance, this crust here moves towards that direction and the other moves towards the opposite direction, causing a disalignment with their surface, with their component, okay. So there are disalignments in between them, okay. So that is shear stress. They tend to rub against the other, and they can produce the strongest earthquakes, okay. So that's all for the different types of rocks and the geological processes on how rocks are made, on how rocks are formed. If you have other questions or concerns, you may contact me directly through my MS Teams channel, or you can chat me through MS Teams and raise your concerns. Okay, so this ends the discussion. I hope you have learned something, and stay safe, everyone. Let's call it a day. Goodbye and God bless.